Python people, the Circuit Playground Bluefruit comes with a light sensor, and so what we're going to do is learn how to use the light sensor. We're going to plot it using the plotter in Moo, and your challenge exercise is going to be to create a fridge alarm. Now, in order to set up the light sensor, we have to import some libraries here. So you're going to import analog IO and simple IO to set up the light sensor. It's very easy and very similar to the other things that we've done. So we're going to refer to the analog IO library that we just imported by saying .analog in. What we're doing is we're saying, hey, create something that's going to take some input from analog, meaning non-digital signals here. And in this case, it's going to be the input that comes through the board's light sensor. So by doing all of this stuff, we've got this thing that's set up as light, and that can return a value of the light that comes in. So now that we've got this all set up, what we're going to do is we're going to modify our while true loop to print out the light dot value. So that's the value of the light sensor that we've got, and then we'll just wait for 1/10 of a second in between. Let's give it a shot. Now over here in Moo, for our challenge exercise, you might want to refer to the code that you've already written. I'm going to assume at this point that you've gone through and done the accelerometer challenge for the don't move my stuff alarm. I'm going to create a block comment in here, and what this is going to do is it's going to comment out everything in between. If I do 1, 2, 3 double quotes in Moo, the lines below the triple quote turn green, indicating that they won't execute. And then I'll end this commented block of code by putting 3 double quotes at the end of it as well. So that means this is all commented out. If I remove both sets of triple double quotes, I'll remove the comments. I can also copy and paste from what's inside here. So this is a nice way to temporarily park code aside that you might want to use later on. Now I'm going to go up here and I'm going to import analog IO, and I'm also going to import simple IO. Now that I've done this, I'm going to set up my light sensor. And the way we do that is we simply say light equals, you could name it anything else, but light is a good name, analog IO dot capital analog in open parentheses, and that's at board dot and all caps light. So now that we have this set up, we can go right down here into our while true loop. Just before I've got my triple double quotes, I'm going to type in print, and then remember, for things to print out in the plotter, we need to have them in a tuple, which means we have to have yet another set of parentheses here. But I'll just say light.value, and because there's only one value, we have to put a comma after it. I know that looks weird, but it's just a requirement for Python and using the plotter and Moo. And then we're going to say time.sleep 0.1 to wait 1/10 of a second during our readings. Now I'll go up here to save, and let's take a look at how things look when we go ahead and expose our serial monitor and our plotter. So here is the save, and we can see it's printing out some values. It spikes up right to around 4,000. I'm going to put my hand over it, and look, it goes down to 0. Take my hand off, and we can see the light is sensing up, down to 0. You can very slowly move your hand to let a little bit of light in. And now I'll turn on a brighter light in my office. And we can see we get a spike up in value as well for that. So that's how the light sensor works. And now that you know how the light sensor works, let's go ahead and try a challenge problem. And this is going to be the fridge alarm. So the idea is, if you're like me, maybe you've had a resolution to try to drop a few pounds, you snack late at night. So if you want to issue an alarm when you open the door, we're going to create a fridge alarm for that. So the way that this should work is pretty similar to the alarm that we created for the motion alarm. When the alarm is first turned on, or when your CPB is first turned on with this program on it, we're going to shut the alarm off. We're going to set an alarm flag set to false. Then when we press button A, that should arm the alarm. What we're going to do is we're going to wait 4 seconds after arming the alarm to give us enough time to close the refrigerator door without setting off the alarm. If the alarm door is open and the refrigerator light goes on, we should play a loud, obnoxious siren noise. And if we want to disable the alarm, pressing button B after the alarm has sounded should shut the alarm off. So you can pause here, you can give this a shot, and then I'll show you one solution. Welcome back. So hopefully you were able to meet the challenge. I'll show you the solution that I came up with, and you can see that it's very similar to our motion alarm. So we kept all of the information that we needed in terms of importing analog I/O and simple I/O, setting up our light sensor. From the previous exercise in the motion sensor, we set all the pixels to black initially, and we set the alarmed flag to false, which means our alarm isn't initially sensing. But then what we do down in our while true loop is I reuse some of the code that I had before, modifying it. If button A is pressed, then we set armed equals true, which arms the alarm. We sleep for 4 seconds here. That just gives us enough time to close the refrigerator door without the alarm sounding. Button B will disarm the alarm and set the pixels to black. This is exactly the block of code that we had used when we were doing our motion sensor alarm. We do a time sleep for 1/10 of a second in here. And then what our test is we're not testing the accelerometer values for X, Y, and Z. We're saying if light.value is greater than 2000. And this might need a little bit of tweaking depending on where your alarm is and how much light you have when the refrigerator door is open. But I think 2000 is a pretty good value here for starters. I'm going to print out the value too. If your CPB was connected to your computer and the serial monitor was open, this would print out the value that was triggering the alarm, so you could see that and maybe tweak it if you needed to. We're going to do pixels fill red, and we're going to play our siren. So let's give this a shot. Here we are back in our Python code. We've already got from our previous exercise here where we had set up our pixels to be black initially and where we set the alarmed value to be false. So what I'm going to do now is I'm actually going to remove the block quotes that I had created previously so I can reuse the code that I've got down here. And the changes I'm going to make include if button A is pressed, I'm going to set my alarm to true, but then I'm also going to put a time delay in here. So if I say time sleep 4.0, that will delay 4 seconds after I set the alarm so I can close my door. Then I'm going to have the exact code that I had previously in here to disarm the alarm and set the pixels to black. What I'm going to do in between here is instead of waiting for every 0.2 seconds, I think 1/10 of a second should be fine. And now I'm not going to be looking for all of these accelerometer values that I've got inside of my parentheses. I'm only going to look at one value in here that has to be true as well as armed having to be true. So the alarm has to be armed for it to go off. But also, and I don't need to have it in parentheses here since there's only one value and I want both of these things to be true, I'm just going to say light.value and I'm going to see greater than 2000 like this. And with this set, let's go ahead and test out our alarm. All right, friends, let's do a real-time test. You can see I've got my Circuit Playground Blue Fruit plugged in. So when I turn on my battery pack, I can see the little green light is on, so it's working. I'm going to go into my fridge. I'm going to place it on top of the Chobani yogurts, sometimes a subject of frequent late-night snacking. I'm going to press my A button to arm my alarm. I'm going to quickly close the refrigerator door. I'm going to wait 4 seconds, and let's see if our alarm works. It works! I'm warned. Congratulations, Coder, you did it.